Hi, welcome back to BC. It's Professor Murray again, and I'm talking about alternating current. I have two diagrams on the board here. One is a DC circuit and one is an AC circuit. And they're very similar, but there's some differences. So let's have a look. Over on the top, my DC circuit, I've got a battery with a positive and negative terminal, and the positive is connected to a switch, the switch is connected to a light, and then light is connected back to the battery. So it's a complete circuit, and the circuit starts and ends at the battery or the DC power supply. Now the AC circuit is also a complete circuit, but it works a little bit different. Here we've got, this is a symbol for an AC power source, and actually it would be a transformer that's giving AC current at your location, whether it's 480, 208 volt, or 120 volt. Doesn't matter for now. So we have our AC power source, and AC transformers are grounded at many locations on the grid. So this is the ground symbol. And what we have here, I've got L1, so that's line 1, and sometimes people call that the hot wire. So I've drawn it in red. The power supply is connected on the hot wire to the switch, and then from the switch to the light, and then the light to ground. And so we still have a complete circuit, and the circuit connects through the ground, through the earth. So somewhat similar, but a little bit different in the way DC and AC are connected. That's it for that part. I'll be back. Hi again, it's Paul. So talking about AC or alternating current electricity. Why is it called alternating current, and what is alternation from? On the board here, this is the way alternating current is normally represented. If you remember in the previous diagram, I had a power source, which I drew a circle with a wave line in the center of it. That wave line, that's to represent a sine curve, and that's the way we tend to represent AC electricity. So this is the AC sine wave, and what it does is it alternates from positive to negative, back to positive, back to negative, and it does that very fast. In fact, it does it 60 times per second, which is why we have 60 hertz here in North America. In Europe and other parts of the world, they have 50 hertz, but it is very similar. So why does it alternate? Let's look at, here I've got a very simple generator. And all I have is, I've got the black casing. A generator's essentially a motor that's used in the opposite direction. So I've got the outside casing of my generator. Inside there's a magnet that's on a shaft or a hub, and the magnet rotates inside the generator. And then in my very simple generator, I have one coil of wire. One end of the coil is connected to ground, and the other is my hot wire coming out of the generator, and that goes to the grid, and that powers electricity. So right now, when I show the magnet kind of in a neutral position, the poles of the magnet are equal distance from the coil, and essentially I would be at this point on my curve where I have neither neutral or neither negative or positive electricity. I just have 0 volts. As this magnet turns, this positive end of the magnet comes closer to the coil, and the electricity goes positive. And then as it continues to turn and the negative comes closer, then I come back down to neutral and back down to negative, and it just keeps alternating back and forth. So the alternating cycle is caused by the rotation of the generator. And the generators are governed so that they always spin at a constant speed, so that they always produce 60 hertz. And they actually have to be very, very close to 60 hertz or a lot of problems happen. But that's why we have alternating current, because we produce electricity with generators. The generators spin a magnet. The magnet spins past a set of coils. In a real generator, there'd be many of these sets of coils, but in my simple one, I just have one. And as they spin past, the coils go to positive and then to negative, back to positive, and it's just a constant alternating polarity on the electricity. So that's why we have alternating current. Okay, thank you.